Okay, so I have a quadratic expression, 6x squared minus 16x plus 10. And I want to completely factor this expression. So I'm first going to look for a GCF. And across my three terms here, I have a common factor of 2. So I have a GCF, and that is 2. Not all expressions will have a greatest common factor. So it's not necessary that you have a greatest common factor. If there is none, then you wouldn't factor anything out, but if you have a quadratic, you just go on to step 2 and use the diamond and the rectangle. Now, if my greatest common factor here is 2, then I am going to have a simplified version of this quadratic expression. So my first term, if I factor out a 2, would be 3x squared. To get me back to that 6x squared, be a negative 8x to get me back to that negative 16x, and a positive 5. So now it's this simpler quadratic that I'm now going to factor using my diamond and my rectangle. So as you know, the squared term of the variable and the constant term are going to go on a diagonal. It doesn't matter which diagonal they go on. I know I've been utilizing the bottom left corner as the x squared, or the variable squared area, and the constant on the opposite across the diagonal. Honestly, you could put those two terms on any diagonal in any order as long as they're on a diagonal, and your factoring is going to end up being the same. It's just that your pieces are going to be in different positions on the outside of your rectangle. So here, let me zoom back in for a minute. Our 3x squared, I'm going to put it down here. As I mentioned, in some videos you might see the x squared term is up above and the constant is on this diagonal, so you might be going this way. I kind of look at it as base times height when I'm looking at a rectangle, so I've always written it across the bottom, but there's nothing that says that writing it on the other diagonal is incorrect. Okay, so those are my two terms. I know in my diamond that the product of the two diagonals is the same. So whatever I'm missing here in the middle, it has to be the same product as the x squared and the constant term, and that product is 15x squared. And I also know that that missing diagonal sums up to the x term. So I also know that those two terms that are missing have to sum to the 8x. So the missing terms, I know the product of the missing terms, and I know the sum of the missing terms. I just don't know the missing terms here on the sides. And I have stated before in the videos that I have done is I don't just randomly try to think of these factors as they pop into my head, because many times we miss a set of factors that aren't quite so obvious. Like think of the factors of 24. A lot of kids might not think of 2 and 12. So they're thinking 8 and 3 and 6 and 4 and 24 and 1, but sometimes that 2 and 12 gets missed. And so if you don't think about it, then you might be stuck. Now I'm looking at the fact that I have two terms that multiply to a positive and add to a negative. Well, if that's the case, the only way that can happen is if the two terms here are negative. So I might already put in my negative signs here, so that kind of reminds me of that. So now I'm going to just start with the number 1 and work my way on down to 2, 3, 4, 5, 6. I'm just going to make a list of factor pairs so to get me to 15. And I know both of them have to be negative. So negative 1 times negative 15, negative 2, not a factor, negative 3 times negative 5, negative 4 is not a factor, 6 is not a factor, 7 is not a factor. So I pretty much ran out of factor pairs to get me to 15. Those are really the only two factor pairs that I have. And if I sum them, negative 1 plus negative 15 gets me to negative 30. Well, that doesn't work. I need to get to negative 8. Well, negative 3 plus a negative 5, that does get me to negative 8, so that checks out. So my side terms are going to be negative 3x and negative 5x. Now I know that goes in my missing diagonal. Okay, so it doesn't matter which one I put where. I'll put the negative 3x here, the negative 5x here. I certainly could have put them in a different reverse position. But now I do see that negative 5x times negative 3x multiplies to the same thing as the other diagonal, positive 15x squared, and they also sum to that x term, negative 8x. That's why the diamond is there to help us figure that part out. So if I look at these two terms on the bottom, they have a common factor of 3 and I have a common factor of x. So I know I'm going to pull out a 3x. Down below here, I only need a 1x when I multiply back to get my 3x squared. 3x, to get a negative 3x, I need to multiply by negative 1. Okay, so now on the upper row, I already have an x factored out from the negative 5x, so I need a negative 5 over here. And then I'm just going to check out. I have a factor of negative 1 below the 5, and I have a factor of negative 5 out to the side. Negative 5 times negative 1 multiplies to positive 5. So I know I have my 3x minus 5. That's one of my binomial factors. The other binomial factor is the quantity x minus 1. Now don't forget that I already factored out this greatest common factor of 2. So I actually have 3 factors here. So when I completely factor, I have to consider my GCF of 2. Then I'll consider my 2 binomial factors. So the complete factorization of 6x squared minus 16x plus 10 is 2 times the quantity 3x minus 5 times the quantity x minus